about their vision for the future. So it has great insight into what's going on and what will be going on over the next several years in telecom. So, Brian.
Good morning, everyone. Hope everyone's had their coffee, they're wide awake, and in for a fun day today. So, in thinking about 5G, normally we would be writing a FIT report on that at this point, but as I've mentioned, I'll be changing jobs on Monday, so not going to do that. I'm not going to be writing as much as I used to. But we've been thinking about 5G in terms of what is it going to be, and I think one of the keys of 5G is going to be that unlike the last 4 generations, this one will have the air interface won't be the driving element. As we've seen with everything before this, it's been the air interface that's been the main driver of how the technology evolves. We tend to look more at 5G as being more control plane intensive, and I'll probably mention that word a couple of times. And we look at 5G as the wireless Internet of everything. We're going to see, a very highly flexible control plane intensive architecture capable of dealing with polar opposite traffic patterns. You're going to have or traffic loads. You can have high bandwidth, low latency applications. That is, pushing that around. Live video stream, be an example. High bandwidth, high latency, file transfer. Low bandwidth, low latency, turning a light on. You don't want to wait 2 seconds for the light to turn on in an IoT environment. You want it to turn on. And then low bandwidth, high latency applications, sensor maintenance reporting that can come out at midnight. You don't really care about that. Frequencies are going to be very wide range of frequencies. We're going to have anything from 600 to 60 gig, 600 megahertz to 60 gig, and we have to deal with it all within the same control plane. The control plane's intensive. It's going to allocate this broad range of frequencies to users based on who they are, what they want to do, what radios they can see, and for how long, and what others are doing around them. So again, that's where the control plane keeps coming in to be the master of this environment, this very dynamic environment. There'll also be a higher integration of intelligence across the network, both in terms of the network, the smartphone or the device, and the IoT elements. So there'll have to be a lot more coordination between these items in terms of managing this rather intensive environment. In terms of the time frame, we view commercial networks, stable standards as probably 2020 plus. I mean, we're still defining these standards. We don't have, it's not like where you'd say WCDMA or LTE were at. So our view is it's going to be more of a 2020 timeframe, although Verizon and AT&T are saying they want to have trial networks up and running in 2018. In our view, those will probably be more like some advanced LTE networks to start. And so we'll see where it goes from there. But to me, what's fascinating about all this, and I want to hear more about it today, particularly the speaker on terabit capacity, that I want to see how are they going to do that. Just the fact that there's a lot of options, a lot of considerations, and so we're in a very exciting time in our understanding. This is about as exciting a time in terms of developing an architecture because of its complexity that we've ever seen in our business. So I'm looking forward to the next 10 years. Thank you. Any questions? Sure.
What do you, there are a lot of parts of Texas that haven't even gotten 3G yet.
Yeah.
Is there anything that you see in 5G that makes this technologies upgradable, a better market, reason to take those sections in West Texas that are on GPRS and move them to a 5G?
I think the problem we always deal with that, we were in the UK over the summer on vacation, and there were places where I was just getting GPRS. And these days, if all you have is GPRS, the applications on your smartphone just don't work. So typically what we see cost-wise is that there is that upgrade pattern. You may see them skip a generation, bypass edge, maybe try to go to LTE, but it's going to, two things obviously going to have a big impact on that are, one, frequencies. What frequencies do you have available to use? And lower frequencies would be a better use case for places like that. But then the price points. The older technologies are very cost reduced generally, and so you typically see a migration. Once in a while you see a skipping, but I wouldn't say that 5G is going to be an answer to that coverage issue at this point. What will be interesting about 5G, and we'll probably see this before 5G, is the pooling concept or cloud-based IP RAN architectures where essentially wireless networks look a lot like data centers. and you spin up resources based on demand and loading patterns, and you assign frequencies around a coverage area based on those loads and demand patterns. You don't necessarily have this rigid architecture that we've had all the years where you put up a macro cell, then you put micros, picos, femtos, et cetera, and you kind of layer it, where you move resources around depending on, you got kids at school, so you put more resources around that area. You have traffic delays or traffic jams, you put more resources in that area, and you reassign much more dynamically. That, I think, will precede 5G, and I think that will be a very fascinating starting point in terms of bringing flexibility to that rather intensive control plane I mentioned earlier. Any other questions? Yes?
The cost of 5G versus existing programs, is it going to be an enormous outlay of capital to get this stage?
I think that what I mentioned earlier about these more flexible architectures, one of the things that will attack is cost, because you're not building such a rigid architecture. So that will help. Obviously, the chips for the phones, all those things, we're ways away from that. And given we're going to have so many frequencies, and Ted Rappaport, glad to see him here today, is going to talk hopefully about 60 gigs. It's an area he's been passionate about for years. That we think will be interesting, because you're talking about extremely high but extremely short range. You can make it more flexible, and maybe he'll talk a little bit about massive MIMO or something to help us deal with that. But the cost side of things is we might add more frequencies, more radios. Look at smartphones. You think about the front ends of smartphones; they're a lot more complex now than they used to be. There's costs associated with that. So I don't think that part will be cheaper. It'll be more expensive. But how the network itself and the cost of the network, I think we could probably make it cheaper over time. Especially if we push fiber deeper into the. It's going to be fiber now. It's going to be fiber, except for the radiating element. That's it. Any other questions? Okay, on to the next speaker. Thank you.
Okay, so it gives me great pleasure